Okay, good afternoon, ladies and gentlemen. Let's get the show on the road now. Thank you all for turning out and braving the weather. We've been turning people away. It's been such a sort of popular event. I think the rain has turned a few people away as well, which is a shame. But maybe they're on their way even as we speak. The usual rules apply about phones and things. We are podcasting this talk, so let's make sure it's not interrupted by extraneous noise. It's my great pleasure to introduce James Hannam to you today. Probably the first accountant ever to give a talk about history of science in this series. Is that fair? I'm sure you are. James has a remarkable career in that he worked for 10 years in the city and then thought, is there anything else? And decided to go and stop doing that and go off to Cambridge, History of Science Department, and spend 3 years doing a Ph.D. on natural philosophy and mathematics in 16th century Oxford and Cambridge. And while he was doing that, unknown to his supervisor, he was sneakily writing a book, which had very little to do with his Ph.D. I believe his Ph.D. features about 0.5% in this book. But the book was so successful that it's only been out for a couple of years. It has done so well that it was shortlisted for the Royal Society Book Prize. So it's not only a serious subject and a serious author, but also an extremely accessible and popular and well written book. So I commend it. Our talk today is much more based on the book than the thesis, than the PhD thesis. So I expect we'll all be able to follow it. I expect I'm certainly glad to have the more accessible version. And James's subject, medieval science and religion. I think the summary perhaps is that it's not quite what we think it's going to be. So we're looking forward to a fascinating talk. James.
Thank you very much. And thank you for coming and for braving the weather. I've subtitled my talk, Listening to the Music of the Spheres. The music of the spheres was an idea that the ancient Pythagoreans had, that the universe ran in such a harmonious way that it actually produced a beautiful music, which, although human beings can't hear directly, we are able to experience vicariously through the study and contemplation of astronomy. But I also think that medieval science is a subject that is so widely misunderstood, and there are so many discordant notes that you will always hear when anyone feels that they're addressing this subject, that I'm hoping that by the end of this talk you will perhaps feel that you've tuned in a little bit to what the Middle Ages is really about, and you'll be able to pick up some of those discordant notes. When I first announced that I was going to start writing a book on medieval science, there was some concern as to whether this was a subject that existed at all. Surely medieval science is an oxymoron. And there's no doubt that the Middle Ages have had a bad press for a very long time, and they still do. Just last week, a distinguished journalist in The Guardian, who I know does know what he's talking about and I know has read my book, described the Middle Ages as 1,000 years of largely illiterate brutality. I wonder if he would have felt that literate brutality was going to be any kind of improvement. In Carl Sagan's popular book, Cosmos, there's a timeline of all the great discoveries in science. Up to 415 AD, there's plenty about the ancient Greeks. And then there is a 1,100-year gap before we get to Copernicus in 1543. But the general idea does seem to be that nothing at all happened in science in the Middle Ages. And that is something which I think is completely wrong. And we hear that the science in the Middle Ages, if it did exist, any kind of progress was held back by the Church, that the Inquisition stamped on any sort of free thought. And we're told by slightly more advanced critics that medieval philosophy was all about asking how many angels can dance on the head of a pin. That was a question, I'm pleased to say, which was never asked during the Middle Ages. It was first suggested in the 17th century by a Cambridge writer called Henry More, and was just in the long list of calumnies that the Middle Ages has had to put up with. Voltaire really got the attacks on the Middle Ages going during the Enlightenment. He famously said that medieval philosophy, bastard daughter of Aristotle's philosophy, badly translated and understood, caused more error for reason and good education than the Huns and the Vandals. And that really has been the consensus of opinion ever since. And part of the reason we all think that is we all think that a great event happened in the 16th and 17th century called the Scientific Revolution. The Cambridge historian Herbert Butterfield said that the Scientific Revolution outshines absolutely everything else in Western history, including the Reformation. But it's interesting to note that the concept of the Scientific Revolution actually only dates from the mid-20th century. It's something which wasn't really noticed at the time, and indeed wasn't noticed for a few hundred years afterwards. It was only in the mid-20th century when the discipline of history of science got going, and people believing that nothing had happened of significance during the Middle Ages thought that there must have been this great revolutionary movement which could account for the sudden birth of science in Europe. But that actually is now becoming a view which is not so popular among academic historians of science. If you ask academics now, they will generally become fairly evasive if you ask them what the scientific revolution means. The Californian professor Stephen Shapin was asked to write a book on the scientific revolution, and he began it, "This is a book. The scientific revolution never happened, and this is a book about it." And that pretty much sums up the view in the academy, with the exception of a number of very senior and becoming increasingly senior professors. And I think one of the mistakes that we make when we talk about the scientific revolution is the belief that science sprang into existence at some point in the distant past. And I think we need to understand exactly what we mean by science. This, of course, is a great scientific institution which was founded in the 17th century. But I'm not sure that science actually existed in the way that we understand it today at the time that this institution was founded. This institution, I think, is considerably older than science, modern science, certainly. So who did invent science? Was it the ancient Greeks? Now, they often get credit for this. There are plenty of books with titles like The First Scientists, which are about the Greek achievement, and the Greek achievement was considerable. Unfortunately, it suffered some very serious drawbacks. They could produce this fantastic bit of engineering, not looking quite so spectacular now, the Antikythera mechanism, which you can see in the Archaeological Museum in Athens. And this was a fantastic piece of what we would call clockwork and gearing, which produced the movements of the planets in an armillary sphere. So you had a model, a moving model of the universe. You turned a crank and it went round. And that's certainly very impressive. Unfortunately, in the area of medicine, Greek doctors were far more likely to kill you than cure you. And they simply had no way of testing whether or not their medical theory worked. In fact, they had no way of testing whether their science worked at all. They had no experimental method, except for one or two exceptions which never seemed to catch on as a movement. As far as the Greeks were concerned, the way that you do science is you think about things very, very, very hard. And when you thought about something that hard, it must be true because it's completely rational. And unfortunately, that means that when you get two clever people who disagree, they've got absolutely no way to tell which of them is right because they've both thought very hard. So Greek science is an awful lot of extremely clever theories with no way of telling which one is right. And that, I think, is not what we mean by science. Perhaps science, as we're being told increasingly now, was invented by the Arabs in the Islamic Caliphate. And there's no doubt that there were important breakthroughs by Arabic scholars from the 8th to the 14th century. In particular, Al-Hasan's optical work, which does feed directly into the work of Kepler in the early 17th century and still forms the foundation of optics today. The mathematical achievement of Muslims was also considerable. In mathematical astronomy, that's to say, measuring and modelling the way that the heavens work, they made a number of breakthroughs in more accurately describing the, well, I can't call it the solar system, of course, because they thought that the Earth is at the centre of it, the Earth system, perhaps. And those mathematical ideas find their way directly, unacknowledged, into the work of Copernicus in 1543, and he used them for his own purposes. But the actual mathematical legwork had been done by Persian astronomers a couple of hundred years before. But I think it's probably true to say that there were relatively few great conceptual advances by Arab and Persian natural philosophers. They were still working very much in the Greek paradigm. And also, I think it's also true, although this is quite controversial, that science was never entirely at home in the Islamic environment. It was never taught at the Islamic schools, for instance. It was always something that you had to do as a hobby at the side. It was useful, but it wasn't something which really became very mainstream in that society. So I think, contrary to some of the books which have come out recently, it wasn't Muslims who invented science. So what about the scientific revolution? The great heroes, Copernicus, Galileo, Newton. Well, I don't think even they were doing what we think of as science, because early modern science was still very much the study of God's creation. God was at the centre of all their thinking about nature. It's often been said that Newton was the most religious man of the 17th century among some very stiff competition. And you really can make a case for that. The experimental method, which is so important to tell whether your theories are right or wrong, that was slowly developing. But it hadn't become universal. It hadn't become something which really defined what science is in the way that it has today. It wasn't until the 19th century, for instance, that we see anything approaching experiments in the field of medicine, a scientific area, of course, of great importance to all of us. The scientific problems which were solved by the people in the so-called scientific revolution were the problems really that were bequeathed by the Greeks. 17th century science was the perfection of Greek science. It wasn't so much the beginning of modern science. I think that science began in the 19th century, and I'm probably not alone in this feeling among other historians of science. In the 19th century, you get a professional scientific culture. You get people who are recognisably scientists. You just have to take one look at this couple of Nobel Prize winners to know that they are scientists. A picture of Newton, he's just another bloke in a wig. The experimental method becomes totally universal in science in the 19th century. It got into chemistry in the 18th century, into medicine in the 19th century. Things like geology and other areas, psychology, only actually became something which people felt they could study scientifically in the 19th century. The links between science, technology, and industry is a 19th century invention pioneered by the Germans in particular with their chemical industry. We always imagined that technology is applied science, but actually it wasn't until around about 1850 that science was able to take the lead and actually give something back to technology. The steam engine, we think, well, that sounds like a scientific development. But in fact, the steam engine was invented by a process of trial and error. And it wasn't until about 80 years later that the French physicist Carnot actually set down the thermodynamic equations that tell you why a steam engine works. So as far as I'm concerned, science started. Modern science began in the 19th century, but the story of science begins way back in the Middle Ages. And that there is a continuous development and evolution of thinking about nature from the 12th century all the way up to the present day. There was no great revolution. There were revolutions in individual sciences, but they happened at different times. I don't want to discount the importance of outside influences, in particular the importance of Islamic natural philosophy in the Middle Ages, and what we also took in mathematics from India and inventions from China. But it is basically a European story until very recently. So medieval science, I think, was the beginning of a continuous and developing tradition which is still with us today. And that's why medieval science matters. So I want to deal with, I think, 4 areas where I think medieval science made a specific contribution, which is still with us today. The first of those is that they were open to ideas from other cultures in the Middle Ages. They were happy to suck up inventions from the East and improve them. They were happy to go out and look for the most up-to-date knowledge that was available in other cultures, in Byzantium and among the Arabs. They also, we see in the Middle Ages, the beginning of a brand new institution, the university, which provided a stable home for science to flourish and also to receive a certain amount of protection. I think in the Middle Ages, Christianity provided a set of cultural and metaphysical assumptions that both made science a legitimate field of study and also meant that it was something which made sense conceptually to do. And finally, there were important theoretical advances during the Middle Ages which were incorporated into the work of people like Copernicus and Galileo, essentially unacknowledged by those later pioneers, and only in recent years have we dug back far enough to find out just how much they owed to their medieval predecessors. The first thing that I think we owe to the Middle Ages is that they assimilated the existing knowledge that was available from other cultures. The Carolingians in the 8th and 9th centuries mastered what was left of Roman astronomy. And it's important to realize that Roman astronomy, that's astronomy and science that was written in Latin, were textbooks. They were guides for non-professionals. If you wanted to study science, natural philosophy, and maths seriously in the ancient world, you had to do it in Greek. So when the Roman Empire fell in the 5th century in the West and knowledge of Greek was lost, that meant that the most cutting-edge science of the ancient world was no longer available to people living in the West. Never mind all those barbarian invasions, they just didn't speak the language. But by the 11th century, that began to change. A seminal event was the conquest of Spain by Christians after it had been ruled by the Arabs for about 400 years, from the 7th to the 11th centuries. And of course, Spain did not come completely under Christian control until 1492, when Granada finally fell. But in 1085, the great city of Toledo in Spain fell to a Christian army, and its library was captured intact. And immediately it was realized that there was an awful lot of interesting knowledge in that library that Christian scholars wanted to get their hands on. So clerics from around Europe descended upon Toledo, and they busied themselves translating all the books that they could find. And they included Ptolemy's Almagest, the finest book of Greek astronomy, Euclid's Elements, which is the crowning achievement of Greek geometry, the works of Aristotle, and perhaps most importantly of all, the commentaries on Greek science, which the Arabs themselves had been putting together for the previous 400 years. The Arab scholar, whose name I probably don't pronounce right, for which I apologize, Averroes, was far, far more influential in the Christian West than he ever was in the Muslim world. Because people in the Middle Ages were fully aware that other people knew more than they did. They wrote about the poverty of the Latins, and they were desperate to get that knowledge back. When Sicily was reconquered in the 10th and 11th centuries by Christians, again, the libraries were, I was going to say ransacked, but of course the libraries were visited and manuscripts were copied, and then the original Greek versions of the great classics by Aristotle and Euclid and Ptolemy were also available. It's something of a myth, in fact, that we owe the Muslim world the preservation of the Greek classics. We do have almost all of them in the Greek original preserved via the Byzantine Empire. I think the Arab contribution is much more a question of the original work which they produced, rather than simply passing on the work of the Greeks so that we could enjoy it. I'd also say that these great translation movements of the Renaissance by the humanists didn't really add very much in the scientific sphere. Although that was the time that the authors such as Plato and Homer were first available in Western Europe, the scientific work of the Greeks had existed in Latin for quite some time before that. Indeed, there's a notorious case of Archimedes, whose surviving work was first translated in the 13th century into Latin, but was generally found to be more difficult than people were able to cope with. But when it was first printed in the 16th century, the scholar who prepared that printing also tried to pass it off as his own new translation. And it was another example of the way that the humanists were simply not willing to give the Middle Ages very much credit at all. Indeed, the manuscripts which were prepared under the Carolingian rulers of France in the 9th century were mistaken by some humanists as being Roman originals, because they just couldn't imagine that in the middle of what they had been taught was the Dark Ages, people were actually copying these manuscripts and passing them on. The next important step was the foundation of the universities. The first university was founded in 1158 by the Holy Roman Emperor Frederick Barbarossa. And what's really important about a university is that it is a self-governing corporation. Although it's composed of lots of members, it faces the world with a united front. It doesn't depend on one individual running it or owning it. If it decides that it doesn't like the environment in a particular town, it can simply move. The University of Bologna had a dispute with the town of Bologna in the 13th century, and that led directly to the foundation of the University of Padua, when half the students and masters up sticks and left. The same thing happened here. Cambridge tell us that they were founded in 1209. That's not strictly true. But what did happen in 1209 was that the mistress of an Oxford student was murdered by her paramour, and the townsfolk were so enraged by this that they immediately descended on the lodgings of the student, and not finding him, contented themselves with stringing up all his housemates. The university was not happy about this at all, and threatened to pull out of Oxford, and indeed several did, and found a conducive home a few years later in a bog in East Anglia, where they've been ever since. I think the essential point about universities is their independence, and I think it's something that universities today need to bear in mind, and they have to resist the all-encompassing embrace of David Willetts and the government and maintain an arm's length from our rulers. If you look at the list of the world's top universities, you will find there are almost none in continental Europe. And the reason for that, I suggest, is that most of those universities have been nationalised and turned into degree-making machines. It is the independent universities of the UK and North America which dominate the rankings. Independence was the reason that universities were so important in the Middle Ages, and I think it's the reason that they're so important today. And this is the syllabus that everybody had to study right the way up until around about the 16th century. You begin with grammar, rhetoric, logic, that's what we might call the humanities. And then there's a compulsory course of science, arithmetic, geometry, music, that's kind of musical theory rather than learning how to play an instrument, and astronomy. And then you had to study philosophy, not just natural philosophy, that's to say what we might think of as like science, but also ethics and metaphysics. And the church insisted that you went through this entire course, and it took anything up to about 5 or 6 years before they would even admit you as a student to the theology faculty. So the church said that a grounding in science, among other subjects, was an essential prerequisite if you wanted to study theology. And that meant an awful lot of students did study these subjects, even if, in fact, they were simply trying to get a broad general education rather than actually wanting to become theologians. Probably the most controversial thing that I'll say today is that I think that Christianity, far from being something which has impeded progress in science, has been, generally speaking, rather more conducive for it. The term that I prefer to use is not one of conflict or even one of harmony, but one of creative tension. There's definitely tension between science and religion, but it's not a tension which necessarily leads to conflict and can be mutually enriching. The great myth of the historical conflict between science and religion dates from the 19th century. And it's interesting to note that quite a lot of the things which I had originally assumed were evidence for this conflict never happened. I read, for instance, that the church tried to ban zero. I read this in a work by Peter Atkins, who's an Oxford professor of chemistry, but it turns out to be total fantasy. The church tried to ban human dissection, we're told, but in fact not so at all. The church tried to ban alchemy. No, the church tried to stop fraudulent alchemists selling fool's gold as gold. There's even a ridiculous story about a pope trying to excommunicate Halley's comet, which is still doing a rounds. Now, that's a really stupid thing for a pope to want to do, and sometimes it amazes me that people who consider themselves to be skeptics just swallow all this thing hook, line, and sinker. And it is true to say that there have been authentic conflicts, and we're in the middle of one today over evolution and creationism. But that's not really the whole story. And going back in history, if you're looking for true examples of conflict, it's difficult to find many beyond the infamous trial of Galileo. And even that was far more, I think, about politics than about science. Instead, I want to focus on where I think Christianity was conducive to science. Now, the idea had developed by the 12th century that because nature was God's creation, the study of nature was something which was religiously legitimate. And furthermore, that because the laws of nature were ordained by God, there is a reason to study those laws of nature in order to try and understand God's work. But those laws are, because they are the product of a reliable God, tend to always stay the same. They become laws which are long-term worth studying and worth finding out about. There's no concept that nature is at base chaotic. Nature is at base lawful and therefore is worth studying. Now, of course, if you're a Christian, at least in the Middle Ages, you believe in miracles. But in fact, that doesn't stop you from doing science. John Buridan, a 14th century natural philosopher, one of the great figures of medieval philosophy, was quite clear that although God is quite capable of subverting the laws of nature if and when he feels like it, that doesn't matter when it comes to studying natural philosophy. You are studying the ordinary course of nature. And indeed, in order to recognize a miracle, you have to know what the ordinary course of nature actually is. So the complaint which we sometimes hear that Christians couldn't have been any good at science because they thought that God was simply running the show directly and everything was God's will, is not true at all and doesn't represent medieval thought. And then mathematics only really became integrated into natural philosophy in the Middle Ages. In the Greek world, maths and physics were two very separate subjects. Aristotle was adamant that you can't use one discipline to prove something in another. And although he was happy to use simple mathematical examples in his physics, he wasn't able to integrate the two subjects in a way that science today requires. That first happened in the 14th century. Thomas Bradwardine was actually Archbishop of Canterbury when he died, unfortunately of the Black Death. But before he became Archbishop of Canterbury, he was a noted natural philosopher and mathematician, and he turned Aristotle's physical theories into what's probably the first mathematical formula for motion. It was completely wrong because Aristotle's laws of motion are completely wrong. But mathematically it did accurately describe what Aristotle said the laws of motion ought to be. Finally, I just want to run through some of the actual scientific achievements of the Middle Ages. We weren't simply talking about metaphysics and the philosophical foundations of science. The mean speed theorem is something which actually you will all be familiar with if ever you studied basic mechanics at school. It tells you how far a uniformly accelerating object will travel. And it was first developed at Merton College, Oxford, at the beginning of the 14th century. And it was graphically proved by Jean Buridan's student, Nicole Orem. He ended his career as a bishop. And what I've done here is shown you some of the representations of this graphical proof over 300 years. We've got Hannam's there from a 14th century manuscript. The same proof given in an early printed book published in Venice at the end of the 15th century. And then the proof, in fact, as people now tend to think it's its origin, from Galileo's Two New Sciences. Galileo, of course, made no mention at all of the medieval predecessors he had who had found this proof out long before him. In fact, he very nearly says, but not quite, that he invented it himself. Also in the 14th century, Jean Buridan developed the arguments which allow us to show that even if the earth is moving, we can't feel it. Now, as far as people in the ancient world were concerned, it was blindingly obvious that the earth isn't moving, because they knew how big the universe was, and they knew that it would have to be moving at thousands of miles an hour if you were going to reproduce the phenomena you see in the skies. That, obviously, is ridiculous. It wasn't, however, until the 14th century that Jean Buridan realized that he could use arguments about relative motion to show why we cannot feel the earth moving. Buridan was actually only asking the question, is the earth rotating? And today we're probably, he uses the idea of two boats, and if you're on one and they're both, if you're moving at a constant speed or you're stationary, you can't tell whether it's you or the other boat that's moving. We've all felt it when we sit in a stationary train and the train next door starts moving, and for a moment we feel as if it's us who started moving and that the train next door is stationary, or indeed vice versa. And Buridan realized this, and consequently he realized that actually you couldn't use the physics he had in his day to tell whether or not the earth was moving. And that argument was picked up and appears in a number of books, including, most famously, Nicholas of Cusa's On Learned Ignorance, one of the theological classics of the late Middle Ages. And Nicholas of Cusa was a cardinal, and he thought that the earth possibly does move. He also thought the universe was infinite. It had to be, he said, because God is infinite, and therefore for God to be adequately reflected in his creation has to be boundless as well. So this isn't an obscure book that we can assume just got lost in libraries and nobody would have heard of. It's a book that Nicholas Copernicus certainly knew and used exactly the same argument in his classic De Revolutionibus in 1543 to explain to his admittedly quite sceptical readers why he thought the earth could be moving even if they couldn't feel it. And again, of course, Copernicus makes no mention of his medieval predecessors. He makes plenty of mention of ancient Greek predecessors, sometimes misquoting them in order to make it sound like that they're supporting his argument. And in fact, bizarrely, he says he gets this argument from Virgil, of all people. But that was simply the intellectual fad of the day. You had to show that everything was derived from the ancient world, and the Middle Ages had become something that people were keen to forget. Finally, going back to Jean Buridan, he developed an idea called impetus, which was a way to try and understand how projectiles move. If you throw something, it keeps moving after it's left your hand. Aristotle said, because he thought it was obviously true, that no object can possibly move if there is nothing else moving it. And that hamstrung mechanics for about 1,500 years. Buridan helped with the development of alternative theories of motion that showed that this wasn't necessarily true. And he used impetus, which is very similar to the modern concept of inertia, to explain how it is that objects can continue to move after something has stopped pushing them. And he realized, and this was the key point, that if in the absence of friction or anything else, once you'd given an object a shove, it would keep going forever. Something which today we call Newton's first law rather than Buridan's first law. And in particular, Buridan thought that this explained how it was that the planets moved. We sometimes imagine that people in the Middle Ages thought the angels were pushing the planets around. But in fact, Buridan explained how once you gave the planets a push, because there's no friction in space, they will simply keep going and keep orbiting forever. And that was another idea which directly fed into the science of the 16th and 17th century. So to sum up, I think that the importance of medieval science comes in under three heads. Firstly, I think that a proper study of the Middle Ages totally destroys the credibility of the myth that science and religion are necessarily in conflict. We find that many of the examples of these conflicts never happened. Those that did happen tend to be for reasons which are related to human failure rather than science or religion. And although I have to admit that today we are unfortunately stuck in a very genuine and very real conflict between a certain kind of religious belief, fundamentalism, and the theory of evolution, I think that the way to solve that question is not to go out and say that science and religion are incompatible. We should be supporting those Christians who are arguing for the theory of evolution with their fellow Christians who can't accept it. The second reason I think medieval science is very important is because it does represent the beginning of what must be one of the great achievements of human civilization, and that is to say, modern science. I'm convinced that there was no way that the science in the ancient world was ever going to make the transition to what we call modern science. Conceptually, it was absolutely miles away. And although they came up with lots of clever ideas and they were very, very good at mathematics, it was simply too different from what we imagine science should be to ever have moved in that direction. And finally, I think medieval science is important because it shows us that science does not have to stagnate. It can progress. The scientific traditions of so many countries have risen to a certain level and then stopped, petered out. We see that in China, in India, in the Middle East, in ancient Greece. The only science which continues to develop even to this day is the science that was developed in the West from the 12th century. Thank you very much.